Hello, this is Ashutosh from Catomania, and this video is regarding the doubt posted on our Facebook group. You can also post your doubt and ask for a video solution. If the question needs a new concept to be discussed, then we will definitely make a video and upload it on YouTube. And additionally, we will also give you 5 to 6 questions to check your understanding and to check your concept and to apply the concept in the questions itself. You can even post it on the group and mail it to us at info@catomania.in. So, going to solving the question. This question is a typical type of question which is asked from multinomial theorem. So, as I always used to say, before solving any question, you must have a basic at the right place. So we will go to discuss the basics needed for this question, and we will solve some 5 to 6 problems needed for this type to be discussed, and further we will take this discussion in a Facebook group. So the first basic which is needed for this type is binomial theorem. So what is actually binomial? If I am writing x plus y, is this a binomial? Yes, this is a binomial. So I will just go by a literal meaning of binomial. Actually, what nomial means is term, right? And what by means is by stands for two. So if there are two terms, then it is a binomial. So x plus y, it is a binomial. A minus b, it is again a binomial. X plus x square, again a binomial. X plus z, again a binomial. Or you can say that any polynomial which have two terms is a binomial, right? And we have a binomial theorem to expand it when it is raised to the power n, x plus y to the power n, right? But why do we have a theorem, right? Why do we have a theorem? You must question everything. Why do we have this? Why do we have this? That is the only way to exceed. Suppose if I am asking you to write what is x plus y square, you can definitely write it in some seconds, right? It is x square plus y square plus 2xy. And if I am asking you to write x plus y to the power q, you will definitely write it. But if I am asking you to solve x plus y to the power 10, at that time it becomes quite complex to write the whole expansion. So at times binomial theorem is a very handy theorem, and you can use that in your exams too. So the expansion of x plus y to the power n by binomial theorem is nc0 x to the power n minus 0. Just observe me carefully how am I writing the power of x and y. So what is happening here? Let me change the color first. This is perfect. So if here it is 0, I am shifting the 0 to the power of y and subtracting the 0 from the power of x, right? So I will write the next term. If you are aware of this theorem, then no need to apply your brain. How am I doing this? If you do not know, then just try to grab the idea and try to think about the next term. What will be the next term? So if it is nc1, then the power of x will be n minus 1. 1 will be subtracting from the power of x, and 1 will be raised to the power of y, and it will be continued till ncn. Power of x will be n minus n, that is equals to 0, and y to the power n, right? So there are two main understanding that there are two main things that I want to discuss from here. Firstly, the number of terms. This video is mainly about a number of terms, so we will go how many number of terms are there in this expansion. So if you see, the power of y is 0, power of y is 1 here, and in the next term power of y will be 2, 3, 4, and will continue till power of y equals to n. So you can say the number of terms will be n plus 1. And as I already told you that the power remains constant when you sum the power of x and y. So if you will sum, wait a minute, if you will sum these two, n minus 0 and 0, what you will get is n. If you will sum n minus 1 plus 1, what you will get is n. If you will sum n minus n plus n, what you will get is n. So the power remains constant, it won't change. So you can write as power, sum of power, actually sum of power will remain same. So moving to the next slide, binomial, moving to the next slide, which is multinomial theorem. Citing some example of multinomial theorem. What is multinomial theorem? Multinomial, as already clear to you, multinomial theorem will have multi-terms. So you can write the example. Multinomial theorem is 1 plus x square plus x cube to the power like n, or where n can be anything, or x plus y plus z plus t to the power 5, or anything. Remember the number of terms can be like x plus y plus z plus t plus m plus n plus p plus q. It is not limited to 4. It can extend to you can extend to any value of n, right? And the most important multinomial theorem is, if you see here, the power is continuous, like 0, 1, 2, 3. But if I am writing 1 plus x cube, then the power is not continuous. And this is the most interesting type that we will discuss in this video. And I will ask you to hold on and to watch the video till the end to get how to solve the number of terms in such a type, because that is the most complex type that is asked in the CAT exam. Or you can definitely say that in at least one season, TIME and IMS or CL will ask you definitely 2 to 3 questions of this type. So that becomes quite important to understand what is the idea behind this. So multinomial theorem is mainly of two types, mutually inclusive and mutually exclusive. I think you are quite aware with the idea of what is mutual. Mutual is a common, right? Two friends have a common friend, then that friend is mutual friend of both. So if you say that if I am writing x and x square, then these two things have something in common, right? So these two things have something in common. So the series that includes something in common, like 1 plus x cube, this series is an example of mutually inclusive. X plus x square plus x to the power 9, this series is again an example of mutually inclusive. But if it doesn't include any common term, right? If the series is x plus a plus y plus b plus c plus m to the power 6, this series does not have any common term, does not include any mutual term. So this is an example of mutually exclusive term. Again, mutually inclusive term have two very interesting type. One is a missing term. Missing term is one power is being missed. So if you see, this is an example of missing term. We have the power 0, we have the power 1, but we don't have the power 2, we have the power 3. So let me write it here, missing term. So first is missing term. Missing term. An example is 1 plus x cube, this type expansion. And second is continuous series. Continuous. An example will be 1 plus x square plus dot until the power is continuous, right? This is an example of multinomial theorem. So going to the next question, next slide. Multinomial theorem when the power is continuous. So again, as the example was 1 plus x square. Just take this example and we will find number of terms in this type of in the continuous power series, continuous power multinomial theorem. So if we have to find how many terms are there in this series, simply what we can do is before going through any shortcut, I will tell you how we will approach to a shortcut, or how the understanding goes in applying a shortcut. So if we have to find if we have to find the number of terms in this series, what we will do in this expansion, in the expansion of this polynomial, then what we are exactly going to do is 1 plus x square. We will be multiplying these two terms, right? We will be multiplying these two terms. So as earlier, what we were doing, we were checking the power of y 0 to n. So we are coming that number of term will be n plus 1, but here we do not have any power. Here we do not have any y. Here we do not have any y. So we will go from the power of x. So we will check if we can form the power of x to the power 0. Yes, if we multiply these two, can we form power x to the power 1? Yes, if we multiply these two, power of 2. Yes, if we multiply these two, power of 3. Yes, if we multiply x to the power 2 from this bracket and x from this bracket, and power of 4 if we multiply x square from this bracket and x square from this bracket. So we can form x to the power 4, right? So we do not have any missing power in this series, and the maximum power in this expansion can be x to the power 2 to the power 2, that is x to the power 4, and until x to the power 4 we do not have a missing term. So total number of terms in such series would be 4 plus 1 is equals to 5. Or you can write, or what you can say is, if the series is continuous, then the total number of terms in such type series would be like if we have an expansion of 1 plus x square plus q plus x to the power a to the power n, and in this type series the number of terms will be an plus 1, right? So taking going through some example, what is the number of terms in x plus x square plus x to the power 3 to the power 9? Again you will say where is the x to the power 0? I will say no power is missing, but actually we are doing is we are taking common x 1 plus x square. This is simply this thing, right? So power of 9 will go like this, x to the power 9 and 1 plus x square to the power 9. So all the number of terms will come from this part only. So you can right away write. So you can write the power of terms in this multinomial will be 9 to the 18 and 19. So 19 terms are there in this multinomial expansion. So moving towards the next thing, which is missing power of x, when the expansion is with the missing power of x. So taking an example, expansion is 1 plus x to the power 3 and power is 3. So again, how we will do, we will 1 plus x cube 1 plus x cube, 1 plus x cube. So it is literally equals to multiplying these three terms, three times, one term three times, right? So again we will go by, can we form the power x to the power 0, 1 and till x to the power 9. So we can form x to the power 0. So what I am going to do, I will not write it as x to the power 0. Simply I will write it as, can we form the power 0, can we form the power 1, can we form the power 2, and like this. So can we form the power 0? Yes, we can. Can we form the power 1? Yes, we can. Just take this x from this bracket and 1 from other brackets. Can we form the power x square or 2? Yes, take x and x from this bracket and we can have the power of x to the power 2. Can we form x to the power 3? Yes, simply take this x cube from this bracket and 1 from other brackets. Can we form x to the power 4? Yes. Can we form x to the power 5? Yes. Can we form x to the power 6? Yes. Can we form x to the power 7? Can we form x to the power 7? Now this becomes, now we have to check here, can we form x to the power 7? X to the power 3 to the power 2 will become x to the power 6, and as we already have power as 2 and the maximum power was 3, so we can multiply x only one time, so we can have x to the power 7. Can we have x to the power 8? Can we have x to the power 8? Maximum power is 6. Maximum power is 3, that means total power is 3. So either we can put the maximum power on this, so largest term would be x to the power 9, or we can do it like this, x to the power 6 into 6, then it will give us x to the power 7, or we can do it like this also, x to the power 3, so that will give us x to the power 3. So we want to be able to form x to the power 8, so I am just highlighting this number, so we keep in mind that we cannot form x to the power 8. We can form x to the power 9 as we already saw. So there is one term missing in this series, so the total number of term in this series would be 10 minus 1, which is equals to 9, right? Now solving some other questions so that this concept gets clear in our head, and we don't need to struggle when similar type of question comes in our exam. So take an example, that is 1 minus x square plus x to the power 3. So what we will do is, we will simply write all the powers and just write here till 3, right, or write to the power 5. So what simply will do, we can form 0, we want here to form 1, we can form 2, we can form 3, right? So these terms will come from only one bracket of this 1 minus x square plus x cube. These power that you can form only one bracket of x, and for the next power means that is 4, 5, 6, you will need other brackets. So you can form x to the power 4 by multiplying x to the power 4 by multiplying x square 2 times, right? So also possible, we can form x to the power 4 by multiplying x cube and x square. We can form x to the power 6 by multiplying x cube into x cube, and in the next bracket. So what we will do, we will do is, if we have a continuous series, means we have all terms from this bracket 4, 5 and 6, then we won't be seeing to the further brackets, because if the term are continuous in this bracket, then it will be continuous in the next brackets as well. What only we have to check is last bracket and second last bracket. If the numbers are continuous, means all the powers you are getting from last bracket, then you don't need to check for the second last bracket. If some powers are missing from the last bracket, then you need to check to the second last bracket. And if some powers are missing in the second last bracket, then we will check for the third last bracket, and like this. So in the last bracket we will have x to the power 13, x to the power 14, and x to the power 15. So you can get x to the power 15 by x to the power 3 to the power 5. Can you get x to the power 14? It can be x to the power 3 to the power 4 and x square. So it will be x to the power 12 plus 2, which is 14. Can we get x to the power 13? Now this is a big thing. Maximum can be either 15 or 14, but you cannot get x to the power 13. Like if you are writing it in this way, then the maximum power would be x to the power 10. So you cannot get x to the power 13. So this is the missing term. If there is something missing in the last bracket, then we will go to the second last bracket. So the second last bracket would be 10, 11, 12. How am I writing this bracket? Is power of 3, maximum power in the cluster of 3, 10, 11, 12, 13, 14, 15, right? So can we form power can we form the power as 12? If yeah, we can simply write it as into 1 multiplying by 1. So it is possible. Can we form the power 11? Yes, we can form. Can we form power 10? Yes, we can form. It is like this. So all the terms are continuous in this bracket. So we don't need to check for the further brackets. We are good in this bracket itself. So the missing numbers are 1 and power 30. So you can say the number of terms in this series would be 3 into 5, 15, 15 plus 1, 16. If another term would have been missing, then a term would have been 16. But 2 terms are missing, the number of terms are 14. Now going to the question that was asked. Maximum number of terms in x1 plus x cube plus x to the power 5. So now we will have a cluster of 5, right? So writing 0, 1, 2, 3, 4, 5. So just check that if all the powers are possible or not. 1 is not possible, 2 is not possible, 3 is possible, 0 is possible, 4 is not possible, 5 is possible. Now going to the next bracket. 6, 7, 8, 9 and 10. 10 is possible, 9 is possible, 8 is possible, 7 is not possible, 6 is possible. So we have one missing term from the second bracket as well, so we need to go to the third bracket. It will be 11, 12, 13, 14, 15. 15 is possible, and 9 plus 5 is 14, right? So 14 is also possible. And what is 13? 13 is 8 plus 5. 8 is x to the power 5, and you can say 13 is x to the power 10 into x to the power 3. X to the power 10 is possible, x to the power 3 is possible, so you don't need to see. X to the power 12 is also possible, x to the power 11 is also possible, because x to the power 11 is x to the power 5 into x to the power 6. So all the terms are possible, so you don't need to check for other brackets. But now we will check for the last brackets. So last bracket would be 61, 62, 63, 64 and 65. 65 is possible. 64 is possible or not? Maximum power of 5 would be x to the power 60, and if it is x to the power 5 to the power 12, then it is x to the power 60, and we can accumulate one power of x cube. So it will give x to the power 63. It won't be giving x to the power 64. So it is not possible. 63 is possible. 63 is possible or not? Please just think over it. if 63 is possible, then we need to subtract one power to find x to the power 62, but we do not have any term of x that will form x to the power 62. So 62 is not, 62 is also not possible. 61 is possible or not? 61 is possible or not? If we write it as 55, then if we write it as 55, then it is x to the power 5 to the power 11, right? So 2 power are missing from the maximum power, that is 13 minus 11 power 2. The 2 power are missing, so you can add 2 power here and it will form to x to the power 61. So 61 is possible. Now one term was missing, that was x to the power 62 was missing. So we will go to the next bracket, which is 56, 57, 58, 59 and 60. 60 is possible. 59 again you can say it will be x to the power 50 and x to the power 9. 50 is 5 to the power 10, so we have power 10 and we have power 3 as well, so it is possible. 58 x to the power 55 and x to the power 3, it is again possible. 57 is x to the power 57 will be x to the power 55 plus 12. 12 will come from 5 to the power 9 and 45 will come from 5 to the power 9 and 12 will come from 3 to the power 4, which comes to 13. And 56, it will be definitely possible, it is 50 plus 6. So all terms are possible in this bracket. Only the left out terms are, I am marking those terms. Only the left out terms are power 1, 2, 4, 7, 62. Any other term? Yeah, 64 which also left out. So you can say 6 terms are left out, and if none of the term would have been left out, then the total number of term would have been 65 plus 1, but 6 terms are left out, 1, 2, 3, 4, 5 and 6. So total number of terms missing will be 60. So we are done with the idea. We are done with the concept and question itself. We will post 5 different questions which are based on this type of problem, so that you get a clear understanding and practice on this type of question. And for any type of query, you can also mail it to us at info@cartomania.in, and I will give the group link in the comments below. You can also join us over the group and ask your doubts. Thank you.